Okay, as we start chapter 5, we're going to be continuing with graphing linear equations. So you'll take what you learned in the last chapter and apply it more in this chapter. But this chapter is all about what are called solving systems of linear equations. Systems of equations. And we're going to look at 3 different ways to solve them, each in a separate lesson. So with this first one, we're going to jump into an example, and then we're going to actually look at what it means to be a system of linear equations. So in your workbook, you have the start of 5.1, and we are on page 101. So if you look at activity 1, it says, your family starts a bed and breakfast. It spends $500 fixing up a bedroom to rent. The cost for food and utilities is $10 per night. Your family charges $60 per night to rent the bedroom. So they've given us a lot of information here within this one problem. And they're going to kind of walk us through it. So part A says write an equation that represents the costs. Okay? And what they're talking about with cost is what is it costing you and your family to run this bed and breakfast? Okay? So, first thing we have is the cost, and they want you to use C. So we're going to start out with C equals. They also told you that it costs $10 per night. That was for the food and utilities. So $10 times the number of nights. That's going to be X. That can change. And then the very first thing it told you was that your family spent $500 fixing it up. So we're going to take that into consideration also. So this will give you the amount that your family is paying to run the bed and breakfast. Now part B says write an equation that represents what's called the revenue. Okay? And the revenue is the income. What is your family making off of this running this bed and breakfast? So here's the revenue. They say to use R. So R equals, the only thing you're making is that your family charges $60 per night. So 60 times X. So notice we have 2 equations right here. One for the cost and one for the revenue or the income. So if you look down at part C, they are defining what it means to be a system of equations. Okay, so if you have a highlighter, or you can just underline this or circle it, whatever. But what it means to be a system is when you have a set of 2 or more linear equations. We're only going to be dealing with 2 at a time. So anytime you have 2 equations built around one specific problem or scenario, it's called a system of equations. So when they just simply say, write the system of equations, all you're going to do is write those 2 formulas. The first one was C equals 10x plus 500. The second one, R equals 60x. All you do is write those 2 equations, one stacked right on top of the other one. And that's your system. Okay, as we flip over to the next page, activity 2, we're actually going to look at solving the system. First thing we're going to do is we're going to fill out this table. Okay, same scenario with the bed and breakfast. So again, I'm going to write my equations right up here just so I have them handy. Okay. And then what we're going to do is we're going to fill in this table. So notice we have a row of what X is. Now they told us that X was how many nights. So 0 nights, 1 night, 2 night, all the way up through 11. We have a row for the cost. That's C, what it cost your family to run this bed and breakfast. And then a line for the revenue, how much your family is making off of it per night. So what we're going to do is we're going to fill in this table, and our entire goal of filling in this table is to figure out how many nights is it going to take your family to rent this room, rent this bed and breakfast, and then to make up the cost of what they've put into it. This is called the break-even point. Okay? What point will then they start making money off of this bed and breakfast? So what I'm going to do to fill in the table is I'm just going to use these two equations and plug in whatever x is. So first I'm going to do the whole row for the cost. So our cost was 10x plus 500. So if I plug in 0, 10 times 0 is 0, plus 500 is 500. 10 times 1 is 1. I'm sorry, 10 times 1 is 10, plus 500 is 510. 10 times 2 is 20, plus 500 is 520. So you should see a pattern going on here. It's just going up by tens each time. So I'm going to go ahead and fill in this entire row. And it should get you all the way to 610. And then we're going to do the exact same thing for the revenue. Okay, the equation for the revenue was just simply $60 per night. So $60 times however many nights there were. So 60 times 0 is 0. Obviously, if they're not staying there, you're not making any money off of it. 60 times 1 is 60. 60 times 2 is 120. 60 times 3 is 180. And we just keep going from here. And you end up at 660 on that 11th night. Okay? So what we're going to look at for part B is how many nights does your family need to rent the bedroom before breaking even? Okay, we're looking for that break-even point. At what point will they begin to make money off of this bed and breakfast? So if you're looking at the table, you're going to find the point where the two costs match up. And that's right here. After 10 nights, they have spent $600 to keep this place running, but now they've made $600. So they've made that up. Anything after 10 nights will be pure profit for them. Okay, so how many nights does your family need to rent it? 10 nights. After that point, they begin to start making money. Okay? Now, if we keep moving and move on to activity 3. Okay, now we're going to look at what it looks like to use a graph to solve the system of equations. So this is where what we learned in the last chapter about graphing, where that comes into play. So A says just simply graph the cost equation from activity 1. So the cost equation, C equals 10x plus 500. Okay, well keep in mind your slope on this equation is 10, or 10 over 1. Your y-intercept is the 500. So you plot the y-intercept first. So I'm going to come up to 500. And then for the slope, we need to rise 10 and run 1. So I need to go up 10 and run 1. Well, my graph goes essentially by 50s. This mark in the middle would be 550. Okay? So if I went up 50, I change this a little bit. If I go up 50, that means I would have to run 5 to keep it the same. So I'm going to do that since it'll make a little more sense here. Up 50 over 5 right here. Up 50, go another 5. Rise over run. So here is our cost equation, or cost graph. Okay, and then on B it says in the same coordinate plane you're going to graph the revenue equation. So my revenue equation was just R equals 60x. So on this one your slope is going to be 60, which is 60 over 1. And my y-intercept, since there's nothing else tacked on here, it's going to be 0. So I'm going to plot that 0 first and go up 60 over 1. And I'm just going to kind of estimate where these would be. Up another 60 over 2. Up another 60 over to 3. And I could keep doing this all the way through. Okay? But if you do it right, and everything works out, this is what your line should look like. Okay, and what you will notice is at some point those two graphs will intersect with each other. And that's what C is looking at, is find the point of intersection of the two graphs. So if we look, our point of intersection is right here, and that is at the point 10, 600. Okay, so what does that represent? Well, X represented the nights, and your dollar amount was the y-axis. So what does that mean? At 10 nights, the cost and the revenue were equal. And back before, that's what we called the break-even point. Okay, so whenever we are graphing, if you graph two lines, really what you're looking for is where they intersect each other. And that's going to be the answer to that system of equations. Now, moving on, we are going to actually skip activity 4. We're not going to get the graphing calculators out. We're going to jump over to page 104, where it says 5.1 practice at the top. And we're going to come down. If you notice, number 1 is basically the same thing. You have your two equations, and you're just plugging each one of these numbers in for x. Okay. For 2 and 3, they give you an equation, and if you notice, the equations are all already in slope-intercept form. Really easy to graph. Okay. 4 and 5 says to use a graphing calculator. Again, we don't need to do that. But I want to look at number 6 really quick. Okay. It says there are 26 students in your class. There are 4 more girls than boys. Use a system of linear equations to figure out how many boys and how many girls are in your class. So for it to be a system, there have to be 2 equations. Okay? Well, we know there are a total of 26 students in your class. So the number of girls plus the number of boys has to be 26. They also tell us that there are 4 more girls than boys. There are more girls. So to get the number of girls, you would have to take the number of boys plus 4. Now, in order to solve this, if you notice, the equations don't look the same. Okay, this one has the girls and boys both on the same side of the equal sign. This one doesn't. Okay, but what we can do is solve this one for G. Just subtract B on each side. So you get girls equal negative B plus 26. This one stays what it was. Okay, but then this is like your y equals mx plus b form.